In this video, we are going to look at how the earth wire connected to the metal casing of an appliance protects a user from an electric shock. Consider an appliance with a metal casing and a mains supply. The potential difference between the supply points is 240 volts. Typically, the low potential point is grounded at 0 volt and the high potential point sits at plus 240 volt. The appliance is connected to the main supply by two wires, the live wire and the neutral wire. The live wire is connected to the high potential point, so it is at plus 240 volt. The neutral wire is connected to the low potential point, keeping it at 0 volt. If the appliance is working perfectly, then the current in the live wire should be equal to the current in the neutral wire, and current flows along the path ABWVCD, passing through the internal components of the appliance. With time, the insulation of the live wire wears out, and a typical fault that can occur is that the live wire may come into contact with the metal casing of the appliance. When this happens, the casing will become live, which means it will be at a high potential of plus 240 volt. When a user touches the casing, his feet are on the ground and therefore is at 0 volt, but his hand is at plus 240 volt. Hence, there is a potential difference of 240 volt across his body. Current flows in the live wire, in the casing, and through the user's body to the ground and returns to the main supply. This will result in an electric shock. By touching the casing, the user provides another path for the current to flow back to the main supply. During the electrocution, current flows via the path ABWVCD and the path created by the user ABWXYZ. In other words, the path ABWVCD and the path ABWXYZ are parallel. The first principle you need to understand is this. Any wire that has a resistance is equivalent to a wire with zero resistance connected in series to a resistor with resistance equal to the resistance of the wire. For example, if we have a wire with resistance 20 ohm, then we can represent it equivalently by a wire of zero resistance connected in series to a 20 ohm resistor. Let us replace the live wire, the casing, the user's body, the internal components of the appliance, and the neutral wire by resistors. The live wire has a resistance RL, and therefore we can represent it by a wire with zero resistance connected in series to a resistor with resistance RL. Similarly, the casing, the user's body, the internal components of the appliance, and the neutral wire are all represented by resistors with resistances RC, RH, RA, and RN respectively. We use RH here as the resistance of the human body, which is around 1000 ohm. At point W, the current I supplied by the main supply splits into two currents, I1 and I2, that flows towards the main supply but via two parallel paths, namely path ABWVCD and the path ABWXYZ. The current I1 passes through the resistors with resistances RA and RN towards the 0 volt of the main supply, while the other I2 passes through the resistors with resistances RC and RH towards the 0 volt of the mains supply. The circuit can be further simplified so that it appears more familiar to you as follows. As you can see here, WXYZ is parallel to WVCD. To save the user, all we need to do is short circuit the user. Short circuit means providing a path of least resistance for current. Consider the circuit shown where the 1000 ohm resistor is acting as the user's body. The variable resistor is initially set on a non-zero value. Therefore, current flows through the paths ABC, C1, C2, EF and ABC, D1, D2, EF. But if the variable resistor is set on 0 ohm, then current will stop passing through the 1000 ohm resistor and passes only through the variable resistor. Hence, current will flow along the path A, B, C, D1, D2, E, F alone, bypassing the 1000 ohm resistor between points C1 and C2. In other words, the 1000 ohm resistor has been short-circuited. We apply a similar technique to save the user when he touches the metal casing, which is live. The earth wire is intentionally chosen to be a very low resistance wire so that it provides a low resistance path back to the mains supply. By connecting the earth wire at point X, that is on the casing, current will flow along the path ABW, X, S1, S2, S3, Z back to the main supply and bypassing the user completely. However, this current is very large and can lead to overheating and potentially to a fire. To prevent this, we place a fuse on the live wire and therefore the large current melts the fuse and the appliance is disconnected from the main supply high potential point.